Hello students, welcome to the third session of Physics Bridge course. So now in this session we are going to discuss something different from what we discussed in the last two sessions. So just a minute. Look at this. What do we have here? We have a scale, right? Now if I look at this, this is a 100 centimeter scale actually, okay, 1 meter 100 centimeter scale. And if I ask you to balance this scale on your finger, on one finger, then where do you place this place your finger so that the entire scale balances on that? Okay, where do you think so? Is it 20 centimeter, 30, 40, 60, 80? You all know very well. You keep your finger beneath 50 centimeter. That's it. The scale will balance by itself, right? So it's very easy when I have a single object like this scale and I need to balance that on my finger like this. And so we are going to discuss the physics behind balance in this session. In the first place, why is it so? Why is this balanced exactly at 50 centimeter? Okay, just think of it. Because the mass of the scale left to my left hand side is equal to mass of the scale left to my right hand side. Then the scale balances. Okay, this is a simple scale. We have only one device, one object, and we are balancing it. Okay, and this device is of length 100 centimeter, right? Now, what if we have more than one object with us? Combination of objects placed at different points, or a shorter one, a shorter scale with different objects. Then, how do we balance things? Is there any formula in physics to find the point where the mass, where the entire scale will be balanced? Yes, we do have it. Let us see how to balance things in this class. And now I have a 50 centimeter scale, as you can see, and this 50 centimeter scale shall be balanced now. Okay, I have measured the mass of this scale. It measures 50 gram. Okay, now at what point should I hold the scale so that it balances on one finger? Okay, 20 centimeter? No. 25 centimeter? Will that work? No. 30? 25 centimeter might be, or 30, we don't know. Okay, yeah, you can easily think that the scale shall balance at 25 centimeter, right? Yeah, look at this. Now the scale is balanced at 25 centimeter. Okay, so if I hold even at 24, it is going to fall down. So this is the physics of balance. Why is it balanced at 25 centimeter exactly? Because the reason is you have equal weight to my left and equal weight to my right distributed. That is why you have the scale balanced at 25 centimeter. And now the situation is simple. Anybody can do this. Even if you take a random stick, you can balance exactly at the middle, provided the mass is uniformly distributed. It is not somewhat like the more mass at one end and less mass at the other end. If the stick is uniform, then you can balance the stick exactly at the middle even without knowing the readings. But now the extra thing that comes is, let me draw the 50 centimeter scale representing that here. Okay, this is 50 centimeter reading, this is 0 and this is 50. Okay, let me take few more points in between. Okay, this is 10 and this is 20, this is 30, and this is 40 and this is 25. So here is the actual scale represented here in a line, and these are the few readings that I have taken. If it is only the scale that we need to balance, then it's very easy, keep the finger at the middle and hence it will balance. And now the thing that comes, extra weight added to this scale. What if I put two weights of some mass? Okay, these are the weights of 50 gram each, both of them has 50 gram. Now if I keep one weight at 40 gram and the other weight at 10 gram, where shall we find the balance? Once again we will do the same thing, we will try to adjust practically and see. When I do so, I expect that to balance at 25 again. Why? Because it is at same distance from the center and same mass on both the sides. So I expect that to balance at 25, but I don't know, I expect it. Okay, let us check it now, whether the scale balance at 25 centimeter even when it is added with two weights of 50 gram, one at 10 and the other at 40 centimeter. Okay, let us check it now. So now as you can see, I have two 50 gram weights. This is one and this is the other. Okay, both of them are of 50 gram. And now I am placing one of the 50 gram weight on at 10 centimeter. Okay, at 10 centimeter, and this is 40. Okay, 10 and 40. So now I'll put one weight at 10. Now I'll put one weight at 10 and the other weight at 40. Let us see where will the scale gets balanced. I'll directly put it to 25 centimeter because I expect the scale to balance. Can you see this now? The scale is perfectly balanced. Okay, you can ask, what happens if I remove this weight? Weight on my left hand side becomes more and hence it will not balance properly, and but instead it will fall down to the left of mine. Right? Look at this. Right? At exactly 10 centimeter balances. So this is a quite easy experiment which even you can understand. Yeah, for a simple scale with two weights at equal lengths, it was easy for us to get the balancing length, which is exactly the midpoint again. But now, what if I place place the masses or the weights at different points or different lengths from the center? For example, if I keep say 50 gram at 10 centimeter mark and the other 50 gram at 30 centimeter mark. Okay, if I do so, then where do you expect the scale to balance? Okay, yeah, in this kind of situation, either you can do it practically with scale, try to balance it, that's fine, or you have a method in physics to find where the scale will balance. Okay, that method, this is actually based on center of mass formula, which we will discuss in our regular classes detailedly, but for now I'll give you the basic form of the formula, which says the length. See, this capital X is the length or the reading at which the scale will balance, is equal to sigma or summation mx by sigma m. What is this? Here m represents, it's actually mixi, okay, different masses. I runs from 1 to n. So now, what is m? m is mass of each weight placed on the scale, and x is the reading on which the weight is placed. Okay. Again, see, upon expanding this, this looks somewhat like this: m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3 and so on. If I have more than 3 weights, I should continue. Clear? Very easy. m1 is first mass is 50 gram, x1 is how the point where this mass is placed, which is 10 centimeter. m2 is the second mass and x2 is the point at which this second mass is placed or balanced, and m3 is the third mass, x3 is the point at which it is balanced. Now we have only 2 weights here. Why did I take 3 weights or 3 masses? The reason being, here the scale also has its own mass, right, which I have told you that the scale also has 50 gram. And where is the scale balanced without any weight? That is the center of the scale, which should be considered as x3. Following? m3 is the mass of the scale, x3 is the scale's center, which is 25 centimeter. This has to be considered for the perfect reading. Clear? So totally we have 3 weights, one 50 gram at 10 centimeter, the other 50 gram at 30 centimeter, one more 50 gram which is the scale weight at 25 centimeter, because this is the center. Clear? This 25 centimeter and 50 gram we will add for each problem, all the problems. Okay, let me solve for this case. What happens, or what is the value of x that we get? X is equal to, what is m1? m1 is first mass. What is that? Which is 50 gram into x1. x1 is the point at which m1 is placed, which is 10 centimeter, plus then I have m2, which is 50 gram again, into again I have x2. What is x2? x2 is the point at which m2 is placed, which is 30 centimeter. And now the third one, with very important one, mass of the scale. I have told you that the mass of the scale is 50 gram itself, and the center of the scale is 25 centimeter, right? That is where the scale balances in the absence of external weights, right? If I don't keep any weights on the scale, this is the center of the scale. So this is complete. Divided by m1 plus m2 plus m3. What is m1? 50 gram, plus what is m2? 50 gram again. What is m3? m3 is mass of scale, which is also 50 gram. Simplify this. 50 is common in the numerator. I'll take that out. What is left inside is 10 plus 30 plus 25 whole divided by 50 plus 50 plus 50 is 150. So it is 3 is a, what is the sum? 30 plus 10, 40. 40 plus 25 is 40 plus 25 is 65 by 3. Now, what is 65 by 3? This 65 by 3 is close to, nearly equal to, if I take this as 66, nearly equal to 23. It's actually 22.66. Okay. So the value of this is, or the value of x. What is this x? This is the reading at which this configuration, this kind of arrangement will balance. So x for this becomes 20, nearly equal to, okay, nearly equal to 23 centimeter. So now let us check practically whether this kind of arrangement, where I put 50 gram at 10 centimeter, the other 50 gram at 30 centimeter, balances at 23 centimeter. Okay, let us check it now. So as we discussed from the formula and calculated that 23 centimeter is the point where this kind of distribution will be balanced. What kind of distribution? We will place 50 gram at 10 centimeter, as you can see, 50 gram at 10 centimeter, and another 50 gram at 30 centimeter. Okay, so 50 gram at 10, the other 50 gram at 30. Now, where is it expected to balance? It is expected to balance at 23 centimeter. Okay, let us check whether it balances at 23 centimeter, because what we obtained now, the 23 centimeter reading is from the mathematical calculation and physics formula. Now we will check whether that formula is true or not. See, so now I am placing it at 23 centimeter and balanced. So what we saw from the formula and calculation is true even with the practical situation. So now, as you saw, the one problem that we solved now theoretically can be proven practically, as you saw now, right? And now I'll take one more problem, which is the different kind of arrangement this time, and try to balance it theoretically first and then practically. Okay, so now the next arrangement that I will be taking is, I'll keep 100 gram at 50 centimeter. I'm sorry, 5 centimeter. Okay, 100 gram at 5 centimeter mark. Okay, and then I'll keep 150 gram at 40 centimeter mark. 150 gram at 40 centimeter mark. Okay, clear? Again, I am choosing two weights. Instead of 50, I'll be keeping 100 this time at 5 centimeter and 150 gram at 40 centimeter. And again, mass of the entire scale is 50 gram. You know that, we have to consider that. And this M3 is 50 and X3 is 25, which is fixed, 25 centimeter. They are fixed because the scale balances at 25 centimeter without any weights. Okay. So now, applying the formula or simplifying the values into the formula, what you can see here is 100 gram kept at 5 centimeter. Okay. So M1 is 100 gram into X1 is 5 centimeter plus M2 is 150 gram into X2 is where the 150 gram is kept, which is 40 centimeter plus M3 is 50 gram mass of scale into X3 is 25 centimeter, which is center of scale, divided by M1 plus M2 plus M3. M1 is 100, M2 is 150 plus M3 is 50. Now simplifying this, 50 is common again in the numerator. After taking 50 as the common factor, I will be left with, see, 50 came out, what remains is 2, 2 5s are 10, plus 50 came out, what remains is 3, 3 into 40, 120, plus 50 came out, so it is simply 25 left, divided by 100 plus 150 plus 50, which is 300. So it is 5 ones are 5 6 are, and hence we have x for the second problem is equal to, what is the sum, 120 plus 10, 130 plus 25, 155 by 6. Now upon dividing it, 6 ones are 6 twos are 3 left, 35. This x is very close to 26 are 6. So for this kind of arrangement of 100 gram at 5 centimeter and 150 gram at 40 centimeter on top of a scale of 50 gram weight, we must get the balancing length equal to 26 centimeter. Let us check it now. So now the next balance that we need to do is with different weights. As we discussed, we need to keep 100 gram at 5 centimeter. Okay, see, this is 5 centimeter mark. Okay, and I will keep 100 gram. Okay, 150, the other 50, and I have kept 100 gram at 5 centimeter, and I should keep 150 gram at 40 centimeter, right? So here is the 40 centimeter mark, and now I'll keep 150 gram on top of it, 3 weights. Right now, what was the balancing length? The balancing length that we obtained was 26 centimeter. Okay, just observe carefully, where is 26 centimeter? Okay, and now I'll keep the scale exactly at 26 centimeter, and now it is balanced. So even the second problem that we took is also true practically, as you can see. And here, as you know, weight of the scale also matters, since we have considered the weight of scale even in the problem also. Clear with this? Good. So now this is a question for you to decide where the arrangement will balance. Okay. So now you see, I'll play. This is a problem for you. Okay. I'll keep 50 gram at 15 centimeter. Okay, 15 centimeter, and I'll keep another 50 gram at 5 centimeter. Okay, at 5 centimeter. Now you need to decide where the scale balances. Okay, remember that you need to consider the mass of the scale also, which is placed at 25 centimeter. Okay, you need to assume that the entire mass of the scale is concentrated at 25 centimeter, and move ahead to calculate the balancing length.